Hello everyone, myself Dr. Lakshmi Soujanya, working as an associate professor in the Department of Mathematics from Marri Reddy Institute of Technology and Management. In the previous sessions, we learned how to solve a system of homogeneous and non-homogeneous equations. Now we'll see another method to solve the system of non-homogeneous equations, that is Gauss elimination method. It's the simplest method to solve the non-homogeneous system of equations, but here the equations must and should be in the equal number of equations only. That means if you have 3 equations, the number of variables are also 3 variables only, or else 4 equations with 4 variables. For such type of matrices, for such type of system of equations, you can go with Gauss elimination method. Here the procedure is, we have to consider the augmented matrix A given B. They'll give the system of equations. You know how to write the matrix representation for the system of equations. So for solving the problem, we have to choose the augmented matrix of the form A given B. Augmented matrix means you have to add the matrix B, the column vector B, as the last column for the coefficient matrix A. That is the augmented matrix. You have to convert this augmented matrix to upper triangular matrix. Once you got the upper triangular matrix, then backward substitution, directly you will get the values of x, y, z. For suppose I have some system of equations and I taken an augmented matrix, I converted the system of equations to upper triangular form. Maybe it is in the form of some 1, 2, 3, 4, 0, 1, 2, 3, 0, 0, 1, 2. After converting the augmented matrix to upper triangular form, maybe you will get this form. So here, by back substitution, the solution is obtained means you treat first column as a multiple of x, second column values are the multiples of y, third column values are the multiples of z. Now see, if you are taking the third row, third column, so it's a multiple of z. That means here z is equal to 2. Directly you will get the value. Now you treat second column is a multiple of y, so this is y plus 2 into z, 2z equal to 3. You know z value. By substituting z value here, you will get y as 2 2 is 4, 3 minus 4 is minus 1. Now if you are taking first equation, first column is a multiple of x plus second column is a multiple of y, 2y, plus third column is a multiple of z, 3z equal to 4. You know z, you know y. By substituting these two values here, you will get the value of x. Like that, by back substitution, directly you will get the values. See, we'll follow the procedure what we have done in non-homogeneous system of equations. But instead of calculating the rank values, here directly we are taking the solution by back substitution. That is the difference we are having between non-homogeneous system of equations and using Gauss elimination method. So, I'll take one problem. Here I have chosen one problem. Solve the system of equations x plus y plus z equal to 4, x minus y plus z equal to 0, 2x plus y plus z equal to 5 by using Gauss elimination method. First, you do the procedure like non-homogeneous equations only. Take matrix representation, write down the augmented matrix, convert that matrix to upper triangular form. So, I'll write given equations. The given equations are x plus y plus z is equal to 4, x minus y plus z equal to 0, 2x plus y plus z equal to 5. So, first take the matrix representation. The matrix notation is Ax equal to B, where A is equal to coefficient matrix. A is a coefficient matrix. So, here the coefficients are 1, 1, 1. Next, second equation coefficients are 1, minus 1, 1. Third equation coefficients are 2, 1, 1. So, these are 2, 1, 1. Next, capital X is an unknown vector. Here the unknown vectors are x, y, z, x, y, z. And capital B is a constant vector. Here the right hand side constants are 4, 0, 5. 4, 0, 5. Okay. Now what we have to do? We have to choose the augmented matrix A given B. So now what is A given B? A is 1, 1, 1, 1 minus 1, 1, 2, 1, 1. And you have to add B as the last column for this matrix, 4, 0, 5. Now we have to convert this augmented matrix to upper triangular form. That means you have to convert all the lower diagonal values to 0. So first of all, you identify the diagonal values. Here the diagonal values are 1, -1 and 1. Now lower diagonal, below diagonal values means you have to convert 1 to 0. So first I will convert the values which are in the first column. That means the row operations are for R2 and R3. By using R1 only, we can change the value. The corresponding value in R1 is 1. So for R2, to convert this 1 to 0, you can take row operation as R2 minus R1. To convert this 2 to 0, you have to take R3 minus 2R1. Then this is equal to, we are not changing first row. First row is 1, 1, 4. Next R2 minus R1. Subtract these two rows. 1 minus 1, 0. Minus 1 is minus 2. 1 minus 1 is again 0. 0 minus 4 is minus 4. Next R2 minus 2R1. What is 2R1? If you are multiplying R1 with 2, you will get 2, 2, 2, 8. Now subtract these two. 2 minus 2, 0. 1 minus 2 is minus 1. Again 1 minus 2 is minus 1. 5 minus 8 is minus 3. Now if you are taking lower diagonal values, still you have to convert minus 1 to 0. That means your next row operation is for R3. R3 gives rise to, and the corresponding value in R2 is minus 2. So how we will get minus 1 as 0? You have to take R3 as 2R3 minus R2. Then this is equal to 1, 1, 4, 0, minus 2, 0, minus 4. Next 2R3. If you are multiplying R3 with 2, you will get 0, minus 2, minus 2, minus 6. Now subtract from R2, 0. Minus 2 is again 0. Minus 2 minus 0 is minus 2. Minus 6 minus of minus 4 means plus 4. Minus 6 plus 4 is minus 2. So we got upper triangular matrix. We converted the given matrix to upper triangular form. Now what we have to do? By back substitution. Here back substitution means you have to treat the first column as a multiple of x. Second column values are multiples of y. Third column values are multiples of z. Now from bottom line, from last row to first row, you write down the substitutions. So here minus 2 is in third column. That means a multiple of z. The equation is minus 2z equal to, here the corresponding value in B is minus 2. On both sides we can cancel minus 2 and you will get z as 1. Now take second row. If you are taking second row, first one is 0. Next second one, y multiple is minus 2. So this is minus 2y and there is no z multiple. Again z multiple is 0 is equal to minus 4. Then if you cancel minus 2 on both sides, then you will get y as 2. Now substitute and take next equation. Your next equation is 1 is x multiple plus next y multiple is 1 plus z multiple is also 1 equal to 4. You know y and z. Substitute those two values here. This is x plus y is 2, z is 1 equal to 4. 2 plus 1 is 3. If you are taking 3 to right hand side, you will get x value as 4 minus 3, 1. So your solution capital X is x, y, z. That is x is 1, y is 2, z is 1. This is the final answer. So it's the simplest method for solving non-homogeneous system of equations. So what we are doing here, we are taking the matrix representation for the given system of equations. And then I am taking the augmented matrix A given B. I am converting the augmented matrix to upper triangular form. Here to take back substitution, you remember one thing. First column values are multiples of x. Second column values are multiples of y and third column values are multiples of z. Now, by taking those multiplications, coefficient values, you will get 3 equations. Directly by substitution, you will get the remaining values. Now, let us see another problem on this concept. So, here the second question is solve the equations x1 plus x2 plus x3 equal to 1, x1 plus 2x2 plus 3x3 equal to 6, x1 plus 3x2 plus 4x3 equal to 6 using Gauss elimination method. So, first write down the equations. The given equations are x1 plus x2 plus x3 equal to 1, x1 plus 2x2 plus 3x3 is equal to 6, x1 plus 3x2 plus 4x3 is equal to 6. So take the matrix representation. The matrix notation is Ax is equal to B, where A is equal to is a coefficient matrix. So what are the coefficients here? 1, 1, 1. Next coefficients 1, 2, 3. And next one 1, 3, 4. Next unknowns are here, the unknown vectors are x1, x2, x3. And the constant vector capital B is 1, 6, 6. Okay. So now you have to take the augmented matrix. The augmented matrix is A given B. So what is A? A given B means you have to add the column vector B as the last column for matrix A. So matrix A is 1, 1, 1, 1, 2, 3, 1, 3, 4. Now add matrix B, that is 1, 6, 6. So here you have to convert the matrix to upper triangular form. So you have to convert all the lower diagonal values to 0. Your diagonal values are 1, 2, 4. That's why I am taking lower diagonal values as 1, 1, 3. First you convert the first column values to 0. That means row operations are for R2, R3. So what is the row operation for R2? The corresponding value in R1 is 1. Here also I have 1. So simple row operation, that is R2 minus R1. Similarly for R3 also the row operation is R3 minus R1. Then what about your matrix? We are not changing first row 1, 1, 1, 1. Next 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 6 minus 1 is 5. Similarly here 1 minus 1 0. 3 minus 1 is 2. 4 minus 1 is 3. 6 minus 1 is 5. Now we have one more value. You have to convert 2 to 0. So what is the row operation? R3 gives rise to R3 minus the corresponding value in R2 is 1. There if you get 2, you will get 0. That means 2 R2. Then this is equal to 1, 1, 1, 1, 0, 1, 2, 5. 2 R2. Multiply the second row with 2, you will get 0, 2, 4, 10. Then by subtracting 0 minus 0, 0, 2 minus 2, 0, 3 minus 4 is minus 1, 5 minus 10 is minus 5. Now we got upper triangular matrix. So once you got upper triangular matrix, then what we have to do? You have to take back substitution by treating first column values are multiples of x, second column are multiples of y, third column are multiples of z. Now take the third equation, last row, third row. So now x multiple is 0 plus y multiple is 0 plus z multiple is minus 1. So this is minus z equal to minus 5. That means z is equal to 5. Next on the second equation, x multiple is 0, y multiple is 1 plus z multiple is 2. 2z equal to 5. We know z is 5. Then this is y plus 2 into 5 equal to 5. 2 5 is 10. If you are taking 10 to right hand side, you will get y is equal to 5 minus 10. That is minus 5. Next, take the first row values. First one, x multiple is 1 plus y multiple is 1 plus z multiple is 1 is equal to 1. Now substitute the values of y and z. This is x plus y is minus 5 plus z is 5 equal to 1. 5 are cancelled and you will get x as 1. So your final solution capital X is x, y, z is equal to 1 minus 5, 5. So like this you can solve the non-homogeneous system of equations using Gauss elimination method also. Thank you.